I said yesterday we started exploring our data, which we all saw that data exploration helps you to have a better understanding of the data, and that is also part of the descriptive statistics that we do in order to understand our data. We saw the application of mean, we saw the application of median, we related that to the standard deviation, how the standard deviation helped us to be able to count out the proportion. We equally saw how we can use when our data is normally distributed using skewness and could just see the range of values. And we established that there is a relationship from the normal distribution. We're able to predict if a variation from the average, and that without a variation, which is a standard deviation, you can determine if your data is normally distributed, what proportion of the scores fall within the 65% interval, or plus or minus one standard deviation, plus or minus two standard deviation, and so on and so forth. So that. So today we just want to continue with descriptive and data exploration. And the first thing today, we're just going straight to our content to see how we can explore data. So to explore your data using the same data set we used yesterday, we'll go to descriptive statistics and we'll take on explore. Now, yesterday we saw that since it's a single variable and it's continuous, we put it under the dependent list, and then we put our, go to statistics. If we choose to take our outliers, percentiles, we can plot it, and so on and so forth. And we take continue as we see. So we did that yesterday. With that, we have an output. We have an output. So we're examining the height. So we saw that the height for men, sorry, the height for our variable was 68. And we said with a confidence interval of 95%, we know that our lower bound is 67, our upper bound is 68.5. And the confidence interval gives us a range of values for which we think that the population mean must fall between. So it is it helps us to be able to estimate where our population mean is, given that what we have here is a sample mean. That's what we said. We saw the median, and we established that the median, the mean, and the mode, they're all averages. We have been saying this. They're all measures of central tendency that help us to see how our data or our variable performs around the center. Now, the mean is the most ideal, most frequently used measure of central tendency, given that it applies to so many real-world situations. And we saw that apart from that, there's some situations where we have to use the median, especially if the mean doesn't represent the center. There are moments that we may have more scores above the mean or more scores below the mean, in which case our normal distribution will be said to be asymmetric. It is symmetric when we have equal representation on both sides. I assume I'm talking to people who understand what that is, how the shape of a normal distribution. So it could be positively skewed or negatively skewed, depending on whether the mean is higher than the median or the median is above the mean. So we saw standard deviation, which measures variation. And we said we can use standard deviation to also check for the variation. And apart from the standard deviation helping us to check for the variation from the mean, we can equally use it to be able to establish if we have significant outliers in our data set. Now, using the standard deviation and having our X and having our mean, we can determine whether some scores are significantly deviating from the center. That tells us what we call a standard the Z score, right? The standard Z score. And there is a formula to see and to calculate that. And the rule says that if you calculate a variable and the variable is more than 3 standard deviation above from the Z, more than 3 standard deviation from the mean, then that variable is an outlier or a significant outlier. It deviates from the center. Calculate a score, and the score varies significantly, 3 standard deviation. So we may not go into details of that now. Then we equally talked about using testing for normality, where we said we can test for normality using the Kolmogorov, or we use a Shapiro. And we explained that if our data is not normally distributed, then the Kolmogorov and Shapiro will be significant. If our data is normally distributed, they will be insignificant. That is the principle we established as that is concerned. We can equally use graphs to establish for normality. For instance, when we look at this graph, you can see the graph. What we notice is that in this graph, to an extent, it takes the shape of what? A normal distribution. Most of the majorities of the respondents are crowded around the mean, and as we move away, it gradually reduces. But in SPSS, you can equally superimpose by double-clicking on it. Then you have chart editor that comes up that gives you the possibility to superimpose the normal distribution curve on it. So here, you just have to click here and see we have the normal distribution, we have the uniform distribution, the exponential Poisson as we saw yesterday. And so we have our normal distribution curve superimposed on our data to show us the area of what? Normal distribution. So we saw that yesterday. So we said we can use now also the box plot, which I said you should go and research on what the box plot is and how we can interpret it. Using the box plot, there is what we call the 5 summary statistics. The 5 summary statistics, since you did not do your research, especially somebody who have done the research will understand what we mean by the 5 summary statistics. But the box plot also helps us to be able to examine the distribution of our data. Now, there's some key things that you see from here. The dark line at the center, not necessarily at the center, shows us, this tells us where the median of our data is, right? It tells us where the median, so this line represents the median. If we stretch this line to somewhere here, we'll see that it might be around 67 or so, which is the value of the median, right? And now, since it is the median, for us to understand, you see that we have more, if we look at, for a perfectly normally distributed data set, the median will be at the center, which will correspond to the mean. But now this data is normally distributed, but the mean is not equal to the median, right? The mean is higher than the median. So which means we have more scores above. That's why you see that the gap here, this area is slightly bigger than this one. Do you get that? The area above the median line is bigger. So if we have more scores below, then the area below will be bigger. Do you get that? So that's trying to also verify. So this gives us the area cell, give us the fourth and the first quartiles, right? This area here, this way we have the first quartile, the third quartile, this is the fourth quartile, this is the first quartile, and we have some few cases of extreme values for this data set. So if we look at it, we have respondent 326, right? The height is considered to be an outlier. Respondent 407, respondent 98, respondent 397. Their heights are far more above the general average height in this data set. Do you see that? So we can also use this to identify what outliers. What are outliers? Variables, scores that significantly deviate from the normal, right? Now, if everybody is scoring around 6, 7, 8, and somebody scores 16 on 20, the person is what, an outlier, right? At times, outlier could also mean that we find, for instance, we're naming countries, Cameroon, Nigeria, and we see a place like Lagos. So Lagos is not a country, it's an outlier, right? It doesn't follow the same pattern. So there are some outliers that we need to remove them. For instance, if you discover that Lagos and you're interested in countries and you see Lagos, then you have to remove that one, right? Yes. But if it was maybe we're dealing with countries, African countries, and you name it an American country, you may need to consider whether it is an African country or not, decide whether to retain it. So outliers are just variables that, or scores that deviate from the normal. Everybody is eating rice and you say, no, I want to eat begari. So you are an outlier. You don't follow the pattern. Do we get that? So now we've seen the box plot. It's very, very important. Even at times you're analyzing your data, you can still use this to present your results and explain. If you check on some scientific reports, you'll see that. You can see they use box plot. But we may want to still go back to our explore. Go back to explore. Go back to explore. And under explore now, we want to examine something taking into account our dependent variable or our factor. So we go to explore and we maintain our height. But the question we're asking, does the height differs among men and women, right? So we're trying now to bring a kind of two variables and compare, do a kind of comparative analysis. So we're already deviating from the fact that we're doing univariate analysis to what? Bivariate, which we have to now start bringing two variables together. The two variables we have here is height and gender. So we want to check if height significantly differs and if all of them are normally distributed or not. The overall conclusion for our data is that it's normally distributed, right? The height is normally distributed. So we don't have people that are significantly taller. And so we can already say, we say that everybody has a kind of within the acceptable height. But it would be strange if you see somebody that's 2 meters tall or 2.5, right? You hardly, so we don't expect that should be high deviation when it comes to height. So let's check if we compare now the heights vis-a-vis what? Gender and gender. Because we're looking at entire height, both male and female. We want to now separate and say, let's keep male on one side and women on female on the other side and check their heights and see if we'll gather more information that can inform our decision making, right? So to do that, we come to, let me just reset this. We bring our height here, and we bring our gender here. So we take, what do I need? Let me just take OK for now. So we have our results, right? Let me just clear the first result so that we have something new. So I'm the only one talking. People are just listening. Are people phantom listeners? Nobody's asking a question. Nobody's. So let's look at our output. Now we're trying to do a kind of comparative analysis. From our case summary table, what do we notice? It still supports the fact that when we did our descriptive, so we had more women than men, right? So we're seeing now they're separating the two. And the missing values were higher for men compared to women. That's some little things you're seeing. It might not necessarily be, it may not be important, depending on what you're looking at. So, but now we want to compare the heights and detailed information. So let's look at the mean for male and that for female. What do we notice? Before that, what is our expectation? Do you think that between men and women, which height will be? Oh, higher height. Men. I think we already established that men should be taller in our previous class, right? So, is that hypothesis supported? I think yes. For the average height for men, people of my height is 1.7, which is far higher than this. So for women, it's 65. So women are generally, you know, if you even know in this class, a host, right? Yes, so that is what we are noticing, that generally we have a higher height for men. Now, with this, let's look at the variation. Will variation be higher for men or for women? For women, okay. Let's check. What's the standard deviation? 4.4 for women, and for men is 5. You know, women are generally short, so we don't expect that variation should. Well, they have almost the same height. So basically that is, and for men, let's look at skewness. Skewness for men is positive and for women is negative. What does that imply? What's the implication? In terms of height, how is the unit to explain that? Yes, for men it's positive and women is negative. The height for that of men is more than no, wrong.
Hello, sir.
Yes.
Yes, I think skewness for female is negative because most of the heights for females fall below the mean height, while for male, most of the heights fall above the mean height.
Do we get that? Now, generally, For men, majority of the respondents or the scores will be above, right? Above the mean. That's why we see. But for women, we tend to have more short women than tall women. Do we get the difference? Yes. So if you gather 100 women, you may have 60 that are short and then maybe 40 that are tall. But for men, if you gather 100 men, you may have the reverse. 60 that are tall and then 40 that are short. That's why we have that positive and negative skew, right? So I hope that explanation, thank you for that, is clear. So we have said variation is higher for men, right? So where do we expect to have maybe extreme values for men or for women? Which group would tend to have more? Either people that tend to be far taller or far more shorter, some kind of. Is it for the group of men or women? What do we think? Men. Are you sure? Why do you think that's men? Okay. No, we'll verify that. So now we have time and leave. Often the time and leave help us better to track the extreme values. For the category of men, we do not have any extreme values. Normally, if we had, we'll see it here, right? But for women, the time and leave tells us that we have some 3 extreme values. 3 extreme values. And the 3 extreme values are those with their height greater than or equal to what? 77. Do you see that? So the 3 of them with their height greater than what? 77. This in which group? For women. For women. So it's not uncommon to see a very tall and huge woman, despite the fact that we generally have short women. It's not uncommon. See a very tall, see a short man like that get married to a very tall and huge woman. Is it uncommon? I saw one video like that. There was one pygmy that is married to a very huge tall woman. So generally, variation, but that's what happens, right? What's funny? Okay, I want to synchronize and make sure. Oh, not true. Yeah, maybe if that really holds. So that's what it is. So that is what the stem and leaf help us to achieve, right? Frank, I'll give you the most important thing there. This is it here. We're trying to just check whether they have extreme values. So they're telling us that there are 3 extreme values, right, for the female group, and these extreme values are participants whose height is greater than or equal to 77. That information will be supported by our box plot. Now the box plot now helps us to compare. We're comparing them on a single chart, right? Now we want to compare now the 2 groups, male and female. Now, generally, what do we notice? That the median for men is higher than that of women, right? And so even the average, the shortest person for the women group is taller, let me say, is taller than the shortest person for the women, is taller than the shortest person for the women category, right? So the shortest person for the male category should be around, let me say, it should be 61 or so. But for female, it's 55. Look at that. This 55 here corresponds to that respondent we saw that was 55, right? So it was a shade. I just think that person we saw 55 was a shade. And that the tallest person we saw, which was 85, was a he. So this is the maximum. But here, now, if you compare the median for men and the women, you see that it's already different. We have already seen this in the description. This is just complementary. Remember what you do with figures, you only bring data for visualization, right? It's easier to see, for somebody to understand figures, to see that this one, that women are taller, we tend to have more tall men than women, and that the average height or the median for men is higher than women, without necessarily anybody saying anything. Looking at the pictures, that's what pictures does. It doesn't come and change what we had in the figures. That's why it's seen as repetition. But the way you are analyzing, know that you can use this chart to help you evaluate. Sarah? Okay, it's not Sarah. No, vex. So, with that, any question with respect to explore? So I want you to do a short exercise and share the results with me. So let's go now and explore weights. But before we do that, I want us to state some assumptions. What do we think the relationship will be between weight or let me say, do we expect that the weight for men should be higher than that of women, or they should be the same? For men should be higher. All right, that's what we're expecting. Okay, will variation in weight be higher for men or women? I think those are our hypotheses we need to check. Those are the research pieces we need to. Will it be higher for men or women? Variation. Be writing, because we'll come and check that. That's a question we need to answer. So this is what I expect that you should do. We have been talking for so long. It's time to practice, right? Yes. So based on what we have seen thus far, which means from the one that we started analysis, we are expected to do a descriptive analysis of weight, right? And examine if there is any significant difference in the weight of men and that of women. Check for the presence of outliers in the data. Equally check for the presence the variable weight, right? That's the first thing. Oh, yes. Examine if there is variation in the weight or the significant difference in the weight as gender is concerned. Check if the data is normally distributed. Check for normality. Copy from your friends. Check for normality. Check for the presence or the absence of significant outliers. These are the different groups, which means if one, you check for normality for the entire variable, check now with respect to the different categories and see where we have significant outliers, or if they are not, check whether data is normally distributed and see whether they are normally distributed for men or for women, and so where are the differences. A friend should help you. I repeat. This is what I expect. Descriptive statistics, 2, check for normality. 3, check for outliers, right? And do a comparative analysis as gender is concerned. I don't know how you structure that, but I expect to see that. As weight is concerned, take weight and compare for men and women, for outliers, normality for men and women, significant outliers for men and women. That's what I'm expecting to see. You can structure the question anyhow. Please, I'm giving you 20 minutes for the exercise. After 20 minutes, we will continue. Do it. I want to see your results and interpretation. It's not just running. You run and interpret. So write out your results on Microsoft Word. For those who are online, be ready to share your screen with what you have done and give your results. So I'm giving 20 minutes for that. When we come back, we'll continue with our class. Pardon? She cannot. Then you work with the neighbor. So what do you expect me to do now? No, it's a code that she needs to put. And she did not save the code. So, and the person that gone, I cannot do that now. Your program needs to be activated.